Hello students, as in the last lecture we saw the sums based on the type number 1, which was integral 1 upon quadratic form. So as I told in the last lecture that you have to remember these types as type number 1a, type number 1b, type number 2a, type number 2b, type number 3a and type number 3b. So these are the types which we will be dealing. So as in the last lecture we saw the type number 1a, which was in the form of 1 upon quadratic. So remember, in the numerator it will be always 1, and in the denominator you will have a quadratic form. That quadratic form, it will be in the form of 1 upon ax square plus bx plus c. Not exact quadratic equation. Equation means it have ax square plus bx plus c equals to 0. In the denominator it will be a expression, not equation. Okay, remember this. So 1 upon quadratic. So for type number 1a there are three formulas, as I had explained in the last lecture. Three formulas for type number 1a, three formulas for type number 2a, and three formulas for type number 3a. uh, Here we have one more formula, but basically we apply only the first three. So when you will see the pattern, it is same only. 1 upon x square plus a square, 1 upon x square minus a square, and 1 upon a square minus x square. Here also it is same only, but it is inside the square root. So as in the last lecture we were dealing with this sums based on the type number 1a, and we took one example also, which was 1 upon x square plus 4x minus 5. I hope you all understood this example. And I told just simply you have to follow this 4 easy step to get the answer. So let's have a short revision of what we did in the last lecture. As I told that you have to follow this step. In the step number 1 is what we have to make the coefficient of x square 1, and symbol of x square should be positive. Step number 2, it was you have to apply the third term formula. I hope you all might be knowing what is third term formula. Half into coefficient of x the whole square. With the help of this you will get one answer here. Whatever the answer you will be getting, simply what you have to do in the next step, add that number to alphabet and subtract that number to number. After this adjustment, in the next step, this section, either it will get converted to a plus b the whole square, or it will get converted into a minus b the whole square. After this adjustment, simply you have to apply the suitable formula. As here for this type number 1a we have three formula. If your first term is variable and second is number, and between this plus is there, you have to apply the first formula. First term alphabet, second number, here connection minus is there, you have to apply the second formula. Third formula, I told when you have to apply. And if the symbol for x square in the question already it is minus, then only you have to apply the third formula. Third formula, to guess the third formula, it is very simple. Already in the question itself, it's if they had given that the symbol for x square is minus, then only you have to apply the third formula. So your first one is what? 1 upon x square plus a square is equals to 1 upon a tan inverse x upon a plus c. The second one is 1 upon x square minus a square into dx, that is 1 upon 2a log x minus a upon x minus x plus a, that is inside the mod, plus c. The third one is 1 upon a square minus x square into dx equals to 1 upon 2a log mod. I hope you all might be knowing why we write the formula in mod when we apply log. Okay, so log mod of a plus x upon a minus x plus c. So in the last lecture we took one example As here clearly we can see that the coefficient of x square, it was 1 already, and the symbol was positive. So that was step number 1. In the step number 2, what I told, you have to apply the third term method. Use this formula to get the answer. There is one more formula, as I told, from which you can find your answer, but this is a very easy method where you will get the answer. So here the coefficient of x was 4. Step number 3 is what? Add that number to the alphabet. So make this pair like this, okay? Add that number to alphabet and subtract that number to number. After this part, this section, either it will get converted into a plus b the whole square or a minus b the whole square. As both the terms, if both the symbol for the first section and second section is positive, you will apply a plus b the whole square. If first is negative and second is positive, of course you will apply a minus b the whole square. I hope you all might be knowing, as we used to do this step in 10th standard also. Yes or no? Direct, just you have to see the first and last term, see the square root of this, and convert into a plus b the whole square and a minus b the whole square. 9, as I told, whenever you come across 9, in the next step you can write this 9 as 3 the whole square. Just simply you have to check the square root. Square root of 9 is what? 3. 16, if we come across 16, so we can write as 16 as 4 square. 25 we can write as 5 square. Okay. 2, we don't have square root of 2, so 2 can be written in the next step as root to the whole square. Then after that, apply the suitable formula, a basic adjustment, a basic algebraical adjustment, and then stop your answer. So now we'll take one more example based on this. Here we have one more example. Okay, so now we'll take one example where you will see when the coefficient of x square is not 1. Okay, so let's take one sum based on this. So here the question is what? Integration 1 upon 4x square 1 upon 4x square minus 20x plus 17 into dx. So the first step you will write, let I be the integral function, that is I upon 1 upon 4x square minus 20x, okay, plus 17 into dx. Okay, so as per the rule, we know that what exactly we have to do. Simply we have to follow the step here, or same step we have to follow. So what is the step? Make the coefficient of x square 1. As here clearly we can see that the coefficient of x square is not 1. To make the coefficient of x square 1, simply what you have to do, check the coefficient here. What is the coefficient here? It is 4. So simply what you will do, you will divide each term. You will divide each term. You will divide each term by 4 to make the coefficient of x square as 1. As here clearly we can see that here it is 1 upon 4. 4 will get cancelled, so here you will get x square only. As here 20 upon 4 we can cancel, we can reduce this number if you can. So you have to do this cancellation part. You have to reduce the number and then write 4 ones are 4, 5 is a, we cannot write, we cannot cancel the 17 upon 4, so we'll keep the 17 upon 4 as it is into dx. Now after this step, what you will do, as per the rule, in the numerator we should have only 1, and here we have 1 upon 4. There is one small concept which was there in the first exercise. Okay, whenever you have any constant inside the integral, and suppose here we have any term, algebraical term into dx, any constant inside the integral, we can bring that constant outside the integral. Yes or no? For example, if you have 1 upon 4 and here we have x square minus 5x plus 17 upon 4. We can bring this 1 upon 4 outside, as 1 upon 4 is a constant, yes or no? If we bring this 1 upon 4 outside, okay, so this will come like this, 1 upon 4. Here nothing will be there, means what? Here we'll left with 1. Got the point? Understood? Okay. As there are two methods, the second method is what? How to make the coefficient 1. The second method is very simple. Just bring 4 common, as here we have to make the coefficient of x square 1. So simply what you will do, you will bring 4 common. Okay. So when you will bring 4 common, so inside the bracket you will left with x square upon 20x upon 4, as here 4 was not there, yes or no? And this will be 17 upon 4 into dx. Bracket open and see, you will get this step. Okay. After this what you will do, 1 upon 4 x square minus 5x plus 17 upon 4 into dx. As here clearly we can see that this 1 upon 4 is a constant. We can bring this 1 upon 4 outside the integral. Here we left with 1 upon x square minus 5x plus 17 upon 4 into dx. So here what is the rule? A simple concept is what? Whenever you have any constant inside the integral, this is also constant 17 upon 4, but this 17 upon 4 is attached to this algebraical, this attached to this part, this expression. So we cannot bring this 17 upon 4 common, as 17 upon 4 is attached to this full section, that is not individually here, yes or no? As here clearly we can see that 1 upon 4 is constant. As per the rule, whenever you have any constant inside the integral, just bring that constant outside the integral. As here we'll left with 1 x square minus 5x plus 17 upon 4. So there are two ways in which you can make the coefficient of x square 1. And remember one thing, as per the question, in the numerator we required only 1. So that's why you have to bring this constant outside the integral to make the numerator 1. Got the point? So whatever the constant is there, just simply you have to bring the constant outside and make this part 1. Okay. So there are two ways from which you can present your sum. Okay, after this we'll move on to the step number 2. What is step number 2? We have to apply the third term method. So third term is what? Half into coefficient of x. Here coefficient of x is what? Minus 5 the whole square. We cannot cancel this number, so this will be what? Minus 5 upon 2 the whole square. Minus 5 square will be what? 25, and 2 square will be what? 4. Okay. Now as per the rule, after applying the third term, whatever the number you are getting, you have to add that number to the alphabet. So here we'll make the pair of the alphabet and the number. As per the rule, as per the step, what I told, whatever the answer you will be getting here, you will add that number to alphabet. Will add that number to alphabet. Will add that number to alphabet. Yes or no? Add that number to alphabet and subtract that number to number. So that's the rule here. Whatever the answer here you will get, add that number to alphabet and subtract that number to number. I hope you all understood the sum till here. Okay. Okay. After this part, either it will get converted into a plus b the whole square or a minus b the whole square. Now here the first symbol is minus and the second symbol is plus. Whenever it is minus and plus, of course it will get converted into a minus b the whole square. So how to convert? We'll write this step: x square minus 5x plus 25 upon 4 directly as a minus b the whole square, as it look like a square minus 2ab plus b square. So just simply take the first and second term. The first term is what? The square root of x square will be x, square root of 25 will be 5, 4 will be what? 2, as here minus and here it is plus. As the first term is minus and the second term is plus, so it will get converted into a minus b the whole square. So when you will solve this section a, x minus 5 upon all the x minus 5 upon 2 the whole square, you will get this previous step. So in the next step, I wrote this x square minus 5x plus 25 upon 4 as x minus 5 the whole square. I hope you all understood this step. And this section just will solve this part. Okay, so here you will get what? As here 17 upon plus 17 upon 4 minus 25 upon 4, as here clearly we can see that denominator is same. So plus 17 minus 25. So plus 17 minus 25 is what? Minus 8 upon 4. Yes or no? So here you will get what? Minus 8 upon 4. Or else you can solve this part here also. Okay, here itself. Okay, so as clearly we can see that denominator is same, and plus 17 minus 25, it will give minus 8, and upon 4 was common denominator. Okay, here we can cancel this number. Yes or no? We can reduce this part. 4 ones are 4, 2s are. After this, 1 upon 4 will keep as it is. 1 upon this 1 upon 4 constant, it will be same till last step. Whatever the constant you will be removing outside, see to that you have to keep that constant same till the end of the sum. So x minus 5 upon 2 the whole square minus, here it is what? 2. Okay, so now after this, 1 upon 4, 1 upon 4, 1 upon, as we have to convert the next step in the whole square, as already it is in whole square. This 2 can be written as, in the next step, x minus 5 upon 2 the whole square. As what is the square root of 2? We don't have any square root of 2, so in the next step this 2 can be written as or root to the whole square. Yes or no? Or root to the whole square is what? It is 2 only. You will get the previous step. As in the last lecture we took one sum. As I had explained, whenever you come across 9, we can write this 9 as 3 the whole square. 16 we can write as 4 square. 25 we can write as 5 square. 2, we don't have the square root of 2. Simply what you have to do in the next step, as this section it is in the whole square, x plus to the whole square. If this part it is in whole square, we have to convert, it is compulsory that we have to convert this section also in the whole square. So 9 can be written as 3 square. 3 square is what? 9. You will get the previous step only. Yes or no? 16 can be written as 4 square. 25 can be written as 5 square. Whenever it is 2, as we don't have any square root of 2, so 2 can be written as root to the whole square in the next step. Okay, I hope you all understood this step. Now we have to check which formula will come. We have to apply the suitable formula. As this section is clearly, we can see that minus 5 upon 2 it is with x, so we'll consider this whole section as x only, whole section as alphabet. Yes or no? As minus 5 upon 2 it is with x, so we'll consider this whole section, this part as x, and here it is number, so this is, we'll consider this as a, and here we have minus, so we clearly we can see that this formula look like 1 upon x square minus x a square. As your first term will consider, as your minus 5 upon 2 is with x, so we'll consider this whole section as x minus, and root 2 is what? A number. As I told, a is known as number here, so a, and here we have minus, so we come to the conclusion that for this sum we have to apply the formula number 2. So what is the formula number 2 is what? 1 upon x square minus a square is what? 1 upon 2a log mod x minus a upon x plus a plus c. Okay, so now we'll apply the formula. In the reason you can write the formula. So simply after this step, exactly what we are doing now, as clearly we can see that this integral section look like 1 upon x square minus a square. Now in the next step, what we have to do, integration with respect to x, as we used to write in the derivative with respect to x. Here in the next step, what we'll do now, will apply the suitable formula, will integrate. Actually what we are doing now, we are integrating with respect to x. Now what about this 1 upon 4? We'll keep this 1 upon 4 as it is. As I told, whatever the constant it will be there outside the integral, it will be same till the last step. As this look like 1 upon x square minus a square. What is the formula? It is 1 upon 2a. What is there in place of a? It is root 2 log mod of x minus a. What is there in place of x? It is x minus 5 upon 2. This is x, yes or no? As I told, this part is x and the number part is what? A. X minus a. X minus a. What is there in place of a? It is root 2. Yes or no? So after this, upon x plus a. X plus a. So this part is x plus a is what? Root 2. Mod plus c. Now just a basic adjustment and then you have to stop your answer. Yes or no? Here we can multiply this number. 1 side is 1. 4 to the it is 8. So this can be written as 1 upon 8 root 2 log. Further, can I cross this section? So this can be written as 2x minus 5 upon 2 minus root 2 upon. It is compulsory that if you can do the further step, you have to do a basic algebraical. If you see that we can do the step further, it is compulsory you have to do, otherwise you will lose your marks. As if it contain 4 marks, so you will not get full marks, because when you will see the backside answer, it will be different. So it is very important that if you feel that you can solve this section, you can solve this algebraical section further, it is compulsory that you have to solve till the last step. Okay, so here 2x minus, otherwise you will lose your marks. Okay, out of 4 marks you will get a 3 only. It is compulsory that you have to solve the sum further. So 2x, so this is 5 upon 2 plus root 2 mod plus c. 1 upon 8 root 2 will be same as it is log. Further, now we'll cross this section. So this 2 will go that side to 2x minus 5 minus 2 root 2 upon 2. 2x minus 5 plus 2 root 2 upon 2 mod c. As in the next step, this clearly we can see that in the denominator we have 2 common. So in the next step, we're left with 1 upon 8 root 2 log 2x minus 5 minus 2 root 2, 2x minus 5 plus 2 root 2. Okay, I hope after this we cannot do anything, we cannot remove any common, we cannot solve, we don't have any like terms, we don't have any numbers to solve further. So that's the last part. So in this way you have to present your sum whenever the coefficient of x square is not 1. So whenever the coefficient of x square is not 1, so there are two ways from which you can make the coefficient 1, and then after that the procedure, the step will be same. Make the coefficient of x square 1, symbol of x square should be positive. Step number 2, apply half into coefficient, then you will get the number. After this, you have to add that number to alphabet and subtract that number to number. Same and same step you have to follow. As I told, for each and every sum the steps will be same. After adding the number to alphabet and subtract that number to number, this part, this section will get converted into either it will be in the form of a plus b the whole square or a minus b the whole square. And after this you have to apply the suitable formula, so you will get the answer. I hope you all understood the second sum also. So now we'll take one sum in which we'll see if the coefficient of x square is not 1 and the symbol of x square is negative. So we'll take two example now, where we'll see the coefficient of x square is not 1 and as well as the symbol is negative. Okay, so in the first example we'll take the coefficient, already it will be 1, symbol will be negative, and the second example we'll take the coefficient here and symbol negative. Okay, so let's move on to the next example.